Monday, October 20th. Hopefully you are recovering from your awesome parish fair weekend. We are going to have a pre-assessment on section 2526. And here we go. It says solve each compound inequality and graph its solution. So compound inequalities, we need to remember that we have this statement in the middle here, and it is going to be connected to both of these other statements. So we're going to take it piece by piece. There's actually two statements here. It says 0 is less than or equal to m plus 9, and m plus 9 is less than 2. And we're going to solve both of those knowing that, oh yeah, that's good. And we're going to see, and we need to remember is two truths. We need two truths. We need it to be true for this statement and true for this statement. So we're going to solve it. We're going to subtract 9. We get negative 9 is less than or equal to m. And remember, some students want to rewrite it with the variable first to help with the graphing. So since when we solve for m, it's eating the m, the inequality. So when we rewrite it, having the variable first, we need it to still be eating the m. We're not multiplying by negative 1. We're not flipping the inequality for any other reason then. We're just rewriting it with the variable first. We're going to subtract 9, leaving me with m is less than negative 7. So here are my two statements, and I need to see which I need to graph. Let's graph this. Let's make a graph. This is my intermediate graph. We have negative 9, negative 7, and 0. And I'll draw this one in green. So this is a closed circle over negative 9, and it's going to go greater than. So the solutions to this part of the compound inequality look like this. We'll do this in blue. This is an open circle, and it's going to the left because it's less than. So when we want a and statement, where are they both true? Where on this graph are both of those situations true? Well, between negative 9 and negative 7. And we're going to include negative 9 because it's two trues here. And then we're going to go to an open circle at negative 7 because there's only one true. And then everything inside is going to be two trues. So this is my answer. We do not have to write an inequality, but much like in big ideas, if we had to write an inequality for this, we would write it in this manner. This would be the solution set if we had to write it. I'm not going to make you do that. I'm just going to have you graph the solutions, okay? So don't worry about that, but it is important. It is a skill you should be proficient at, but it's not something I'm going to assess today. All right, we see that this is an or statement. So again, there are two statements. There is r plus 6 is greater than or equal to 16, or r over 8 is less than 0. We're going to subtract 6. Yes, I'm at school on Monday on our day off. Is greater than or equal to 10. And then this one, love this one. We're going to multiply by the reciprocal. 8 is it's being divided by 8. The inverse of dividing by 8 is multiplying by 8. So we get it, r is less than 0. And remember, it's an or. When it's an or statement, we need at least one true. So or means at least one true. So we're going to graph it. We have 0, we have 10, We'll do this one in green. R is greater than or equal to 10. That's a closed circle going this way. And R is less than 0 is an open circle going this way. And so where is there at least one? Well, there's at least one here, here, here. There isn't one here. There's none in between here. And then there's one here and here. So if we're going to graph that solution, that looks like this is my answer. And so we'll have a closed circle going to the right, open circle going to the left. And that is going to be our answer. If we had to write it as a solution set, we would write, let me see, I think it's R, correct? Yeah. We would say R is less than 0 or R is greater than or equal to 10. We can't write it as a compound, as one statement. We have to write it as two distinct statements when it's an OR statement. All right, but that's not needed. Again, I'm going to reiterate, I'm just going to have you graph. So do not worry about that part. It's just showing for big ideas. This is an AND statement. -8 plus x is less than or equal to -18. So we're going to get rid of that -8 by adding 8. Leaving us with -4 is less than or equal to x. I'm going to rewrite it because I'm good like that. I like doing that. That just makes it easier for me. There's no confusion on which way I'm graphing. So here are my two solutions. I'm going to do this in green. Oh, let's do we got -10, -4, and 0. So we'll do this in green as a closed circle going greater than 4, -4, excuse me. And this is a closed circle going less than. So that is a closed circle going less than. Now, and needs two trues. Here is 1, here is 0, here is 1. I don't have any area where it overlaps, where there are two trues. So that's weird. And before I just sort of accept it, I'm going to make sure I did my work correctly. So I'm going to make sure I did my math correctly, check it. I got my inequalities. X is greater than -4, greater than -4 goes that way. Less than -10. Okay, so my answer is going to be no solution. And it's okay to check. Take your time. Make sure that it makes sense mathematically. Just make sure. Take the time. Ooh, fractions. Okay, so this is an OR statement, so we'll write them out. 2/3 greater than or equal to 13/6, or k plus 1/4 greater than 1/2. We're going to subtract 2/3. Now, 2/3 doesn't have the same denominator, so I'm going to write 2/3 as sixths. So -2/3 is equivalent to -4/6, so we have common denominators. K is greater than or equal to, and that'll give me 9/6, and we should reduce that. We should simplify that fraction. Let's subtract 1/9. All right, now this is an interesting one. I'm going to write -1/9, but Mr. Mack, that's not a common denominator. I'm going to have to find a common denominator between both of them. Oh, that's a 4, not a 9. Hello, Mr. Mack. Hello. That's good. See, I went back and checked because my poor handwriting made it look like a 9. But it still doesn't have 1/4, 1/4. So we're going to actually have to change 1/2 to 2/4. And that leaves me with k is greater than, that looks like an equal to. My handwriting, this is not good. Not a good day for handwriting for Mr. Mack. And that leaves me with 1/4. And it's an OR statement. So let's do this. Let's do 0. 1/4 is smaller than 3/2. And let's do the colors. This is closed circle going to the right. This is an open circle also going to the right. Oh, I like that. That's pretty tricky. So we do have to rewrite this one. 0, 1/4, 3/2, and we're going to have an open circle going to the right is going to be our solution. There are no trues. There are no trues. There's 1, 1, 1, 2, 2, 2, 2. But remember, I want at least one. So these are solutions because there's at least one here. In fact, there's more than one along this part. So that's a little tricky. Good. This is an and statement. Notice also we didn't discuss this on problem number 1, but it is numerical order, -18, 17, and then they are less than signs. So we're going to write our two statements. -18 is less than or equal to 7 plus 5x. And we're going to write the other part. Now that's a little, there we go. 7 plus 5x is less than or equal to 17. What I find students is that they just write 5x is less than 17. They chop off this 7 plus, which is wrong. We got to have all of the middle piece. You're going to have the 7 plus 5x to both of the values. So let's subtract 7. We get -25 is less than or equal to 5x. Divide by 5, divide by 5. And -5 is less than or equal to x. Let's write it with our variable first. We'll subtract 7, subtract 7. 5x is less than or equal to 10. Divide by 5, divide by 5. And x is less than or equal to 2. It's an and statement. We got -5, we have 0, we have 2. Let's do this in green. So closed circle going to the right because it's greater than. Closed circle going to the left because it's less than. And we need the intersection, the overlap of both of those. -5, 0, 2. We're going to have closed circles between -5 and 2. And that would be my solution. This is an or statement. Let's rewrite them. I like rewriting them opposed to having them crunched in that space. I like to see my work, even though my handwriting on this pen tablet is not the best. Let's get rid of this 2 first. -3p is less than or equal to 15. Divide by -3, divide by -3. We need to notice that we are dividing by a negative, both sides by a negative, so we must flip the inequality sign. That's important. So make sure that you note that you divided both sides by a negative, meaning you need to flip your inequality. Let's -1. 7p is less than or equal to 21. Divide by 7. That's not a good 7. Divide by 7. P is less than or equal to 3. And it's an or statement. Let's do this in green. Oh, let's get those numbers down. -5, 0, and 3. Green is closed, going this way. And this is this, going this way. And remember, or is at least 1, so there's at least 1 here. There's 2 through here. There's at least 1 here. So my answer is going to be all real numbers. Whoops, I don't want it in blue. So my answer is going to be -5, 0, 3. This is how you graph all real numbers. You have a line above it showing that it goes to infinity that way and to infinity that way. You don't have to write all real numbers. You need to graph it. So let's see this. Two statements. We got and statements. Negative 20 is greater than or equal to 6n minus 8. And, ooh, these are greater than signs. That's interesting. It's going to be interesting to see because and statements typically are less than statements. But this is an and because it's between these two, and it has to be greater than, it has to be less than this and greater than that, which to me seems very difficult, but I'm not going to make any assumptions. I'm just going to solve it and see what ends up happening. We'll add 8, but I'm aware. Notice my attention. I am hyper aware of something being strange about this. So we're going to take special care and cautionary steps at making sure that we do it correctly. We'll divide by 6. Divide by 6. N is greater than or equal to 3. And this is an and statement. That's negative 2, 0, 3. Let's do this one in blue. Oh, close circle. N is less than. I probably should have. Sorry, I'm going to stay consistent. I'm going to write my variable. I'm going to write my variable first. N is less than or equal to negative 2. It's eating the negative 2, so when I rewrite it, so I know it's going less than. Let's do this one. Close circle, going to the right because it's greater than, and it's an and I need 2 trues. I only have 1. I have 0. I have 1. So this is also no solution. And I kind of knew that we were going to get something crazy like that because that was really hard. It's hard for something to be greater than 10 and less than negative 2. That doesn't tend to work like that very much. All right, let's write my two statements. 2x minus 3 halves is greater than or equal to negative 5 halves, or 2 minus 4/3 x is greater than or equal to 16/3. So let's get rid of the addition and subtraction. 3 halves. These are like denominators, which I like. That makes it more conducive. 2x is greater than or equal to. You have negative 5 and positive 3, which is negative 2 over 2. I can simplify that to negative 1. Now, we can divide by 2. That's okay. There are no fractions here anymore. That fraction was simplified to negative 1, and we get negative 1/2. I divided both sides by a positive, so I don't have to flip it. Excuse me. Let's minus the 2. And instead of doing 2, I'm going to do 6/3, because 2 is equivalent to negative 6/3, and we can have like denominators. We get negative 4/3 x is greater than or equal to. Like denominator, 16 minus 6 is 10/3. I don't have to simplify it. We have fractions, and they're multiplying, so I'm going to multiply by the reciprocal, negative 3/4. And that leaves me with x. I'm going to flip the inequality sign. Don't forget to flip, because I multiply both sides by a negative. And I'm also going to cross cancel denominator, numerator, and then 2 goes into both of those. 2 goes into 4 2 times. 2 goes into 10 5 times. I'm not going to forget that negative. So I got negative 5 over 2. And it's an or statement. So important to be able to see and visualize this. Make sure you see the work. So if we do this, and let's do this, well, let's write our fractions. Negative 5 halves is to the left of negative 1/2, which is to the left of 0. Let's do this in green. This is a closed circle. going to the right. This is a closed circle also, going to the left, and then that's going to be my answer. So let's put that, -5/2, -1/2, 0. Let's do this, going that way. Let's do, whoop, I almost made a mistake, caught myself, not at 0. -1/2. And this would be your answer. Good. All right, solve each inequality and graph its solution. Notice with these, we have absolute value bars now. So absolute values, remember, is a distance. So we know that what would have a distance of 4? Well, 4 and -4 would have a distance of 4. So we're going to take what's inside and we're going to pull down that inequality. And then we're going to write that same thing inside, but this time we're going to flip the inequality and make it negative. Hence why we flipped, because we introduced a negative. And so we flip that inequality. It has to be outside of that distance. Good. All right. So further away. And then and this is a less than sign. That's something important that we need to discuss. When it's less than or equal to or less than, it's going to be an and statement. So in this case, it's a less than sign. So we know it's an and. So it will be and between those two statements. Let's add 10. Add 10. Gives us r is less than or equal to 14. Let's add 10. Add 10. That is r is greater than or equal to 6 with an and statement in between it. Let's graph those. We have 0, 6, 14. Let's do this in green. Closed circle going to the left because it's less than. This is a closed circle going to the right because it's greater than. It's an and statement, so we're looking to see where it overlaps, not in blue. Almost did it again. 0, 6, 14, and we're going to have a closed circle and graphing it between 6 and 14. That would be my solution. Those are all the solutions to that. This is a less than, less than, less than. So we're going to write the two statements. 4a is less than or equal to 32. 4a is greater than or equal to -32. It's an and statement. We're going to divide both sides by 4. A is less than or equal to 8. Divide both sides by 4. A is greater than or equal to -8. It's an and statement. -8, 0, 8. Let's do this in green. Less than 8. Let's do this in blue. Greater than or equal to. And it's an and statement, so I need the overlap. So we get -8, 0, 8. And we get this as our solution. Here's our greater than. So when you have a greater than or a greater than or equal sign, it's going to be an or. And the way that I remember, greater than. Okay. So we're going to write two statements with an or statement this time. -3 plus x is greater than -1, or -3 plus x is less than 1. We change the sign. Notice negative to positive, and we had to flip the inequality sign. We're going to add 3, x is greater than 2, or we're going to add 3, x is less than 4. So greater than 2 or less than 4. Let's do those. 0, 2, 4. Do this in green. Open circle, greater than 2. Open circle, less than 4. So this is an or. We only need at least one. We don't only need, we need at least one. We have one, we have at least one here. We have 2, we have at least one again, and at least one. So that answer, okay, so that's going to be all real numbers. 0, 2, 4, and then we're going to draw a line with arrows above it. You must graph all real numbers. You can't just leave the graph blank. That doesn't make sense to me. So make sure that you're doing that. This is less than, so we know less than is an and statement, so we'll write these two. Negative 3/5 m is less than or equal to 2/5. I'm going to have to move that over. And negative 3/5 m is greater than or equal to negative 2/5. So that's fraction is multiplying. So we're going to multiply by the reciprocal, which is negative 5/3. Negative 5/3. Negative 5/3. That's going to cancel. We multiply both sides by a negative, so we'll flip that inequality sign. The 5's cancel. 5 in the numerator cancels with 5 in the denominator. We get negative 2/3. So notice that we flip the inequality because we multiply both sides by a negative. And then these 5's cancel. That's good. We're going to multiply this by negative 5/3. Negative 5/3. M, we flip it again because we multiply both sides by a negative. The 5's cancel and the negatives cancel. Negative times a negative is a positive, leaving you with 2/3. It's still an and statement. And we just show that we flip the inequality sign because we multiplied both of them. Okay. Here we are, negative 2/3, 0, and 2/3. Let's do this one in green. Close circle, greater than. This is close circle also, and less than. So it's an and statement. We need where it happens both times. Third time of drawing that line by accident. Almost did it again for a second time. Negative 2/3, 0, 2/3, closed circles going between negative 2/3 and positive 2/3. Good. All right, you should be getting these. These are good. All right, now we must remember to isolate the absolute, not that absolute, the absolute value bars first. So this is not isolated. We're going to have to, before we judge whether it's an or an and, we have to isolate it. So we're going to add 1 to both sides, which gives us 6 times the absolute value of r divided by 3 is greater than 6. So 8, no, not 6, that's 8. We're going to divide by 6. Divide by 6. We get the absolute value of r over 3 is greater than 4/3. And now we can evaluate. Now we see that it's an or statement. Or statement. So we know that we're going to write two statements. R divided by 3 is greater than 4/3. Or r divided by 3 is less than negative 4/3. We're going to multiply by 3, which is the inverse of dividing by 3. Gives me r is greater than 4. The 3's cancel. 3 in the numerator, 3 in the denominator. We're going to multiply both sides by 3. Gives me r is less than negative 4. It's an or. So we have negative 4, 0, 4. Let's do this in green. Open circle greater than 4. Let's do this in blue. Open circle less than negative 4. So my solution is going to be this. Negative 4, 0, 4. Open circle, wings. Open circle, wing. That is number 13. Number 14. Here we go. Isolate first. We will add 5 to both sides. The absolute value of n over 3 is less than or equal to negative 1. It is a less than sign, less than or equal to. So that means and. So we'll write those two statements. N over 3 is less than or equal to negative 1, and n over 3 is greater than or equal to positive 1. Multiply by 3. N is less than or equal to negative 3. Let's multiply both sides by 3. N is greater than or equal to 3. And negative 3, 0, 3. So let's do this in green. Close circle. Less than negative 3. That's also a closed circle, greater than 3. It's an and statement, so there's no overlap. So this answer is not in blue. This solution is no solution. There's no two trues. No solutions. Or solution. Okay, let's again isolate. We cannot combine 2 minus 2, that's subtraction. And we have this multiplication of the absolute value. We can get rid of this 2 first, which is the best idea, leaving us with negative 2 times the absolute value of a plus 3 is less than or equal to negative 2. Let's divide both sides by negative 2. And we've isolated the absolute value. We need to flip the inequality sign because we divided both sides by a negative. And we get this statement. It's greater than. So I know that this is an or statement. It's an or statement. So I got to write my two statements. A plus 3 is greater than or equal to 1, or a plus 3 is less than or equal to negative 1. Let's solve it. Negative 3. A is greater than or equal to negative 2. Let's isolate it. A is less than or equal to negative 4. It's an or statement. Or statement. Let's draw our line, number line. Our numbers are negative 4, negative 2, 0. Make sure you write your numbers in numerical order. A is greater than or equal to negative 2. That's a closed circle going greater than. This is closed circle going less than. It's an or statement, so we can have those wings. We need at least one. So my final answer is going to be, yikes, that's a horrible. It's going to be closed circle with wings. And the last problem. Ooh, look at that. We've got things being subtracted, things being multiplied, and we've got absolute values. Let's get rid of the things being added and subtracted first. leaving me with negative 5 halves times 3/5 v is greater than, they have like denominators, negative 9 and positive 7 is negative 2 over 2. I'm going to rewrite that because I like simplifying. That's negative 1. Now we've got negative 5 halves. We have to multiply it by its reciprocal, negative 2/5. Isolating my absolute value of 3/5 v, I multiply both sides by a negative, so I have to flip that. Negative 1 times negative 2/5 leaves me with 2/5. So make sure you notice that you flip the inequality sign. And now it is a less than. Less than, it means an and statement. So I'm going to write my two statements with an and. Whoa, getting sloppy. My arm is dead. 3/5 v is less than 2/5 and 3/5 v is greater than negative 2/5. Multiply by the reciprocal, 5/3. 5/3. 5's cancel, numerator, denominator. V is less than 2/3. Let's multiply by 5/3. Multiply by 5/3. 5 in denominator, numerator cancel. V is greater than negative 2/3. It's an and statement. So we got negative 2/3, 0, and 2/3. Let's do this in green. V is less than, open circle, 2/3, open circle, greater than negative 2/3. It's an and statement, so we will find the overlap. The overlap is between negative 2/3, open circles, going like that. That would be my solution. I think that's it. Boom. Okay. All right. That's probably about 45 minutes, maybe an hour. Good luck. Hopefully you learned something. Hopefully you solidified your knowledge and you're ready for the assessment. Good luck.